Welcome to Project SMARTT. I am Dean Phillips, and I am proud to be here today. I'd like to thank Dr. Tantawi and, of course, Dr. Fadan for helping to make this happen. It's my pleasure to be here to talk to you today about manufacturing and technology and how much of an impact you play in this by being involved in the educational side of it, because we couldn't do this without you. So I'd like to get right into it. If we think about all the aspects of manufacturing and all the things that take place, we are in an incredible age right now where we have an opportunity to deal with so much new technology. And it, in some cases, can be pretty overwhelming. So we're going to try and clear things up a little bit today, and I'm glad to be here. Longevity Industries produces educational podcasts focused around manufacturing. The show is called Destiny of Manufacturing. It's one of the shows that we put together, as well as doing AR and VR technologies focused around education and safety. So let me give you my background. I am an innovation strategist with the company Link Systems, as well as a sales engineer for them. I am the president and founder of Longevity Industries, who produces the Destiny of Manufacturing. I'm an international director for SME and an advisor to the SMARTT Manufacturing Group. Why am I here today? I'm here to talk to you about, frankly, your part. What a difference you make in the future of not only students, but manufacturing as a whole and our country's success. This is all up to you. So thank you. Thank you for participating and being here and participating in this educational session. When we think about your part as an instructor, professor, teacher, all of those things, you are building the future. You are playing a part that is amazing for us. When you think about things of how much power you hold in the education, you are like Prometheus. You are the fire bringer and teacher of humans. That is your role today. And I am very glad that you're here. An important aspect for you is getting students interested in learning. When we talk about getting interested in learning, we're trying to build for the future, and that means workforce development education. This could be everything from doing inspections now with drones, delivering first aid technology. All of those are things that students will have an opportunity to do when they embrace technology and STEM curriculums. These are the kinds of jobs that are available in the current times, not the future. This isn't something we're talking about 10 years from now. This is happening right now. So flying drones to inspect work sites, going into hazardous locations. So they're providing a huge safety advantage that we didn't used to have, using robots and drones to go into hazardous locations. Big difference from what used to be. It's gathering information, gathering data in a safe manner. That's what the drone and robot technology can help us with. Not only that, but of course, robots could do a lot of other things, carrying things. Of course, we see drones delivering everything from your groceries to first aid equipment. Workforce development education, the next aspect that we do is getting involved with things like Arduino and Python, programming systems. Kids today have a boundless opportunity for almost very little money to get into things like a Raspberry Pi and programming languages that were not very typically available to most of us. These are some of the largest new tools to gather data. They're using Arduinos for gathering data on equipment, machinery, but everything, even in household appliances. They can be used in all different aspects of your life that you want to track and follow. Analytics. One of the benefits of gathering data is the analytics side, which means not only did you gather the information, but now we're measuring it against a benchmark or some type of data system. And that allows us to then also tie in things like artificial intelligence, which we'll get into in a second. STEM and STEAM's importance. Think about biomedical health, printing healthy cells in additive manufacturing. When I first got involved with additive manufacturing, I used to think, well, I don't know what part art played into it. Then I learned quickly that the creativity side of things allowed kids to envision differently and think about things differently that they wanted to print using 3D printing or additive manufacturing. All of these types of processes to develop new things, new ideas, and take it so much further. It's that creative part that I felt that art brought to it, but I didn't realize that in the beginning. So I did want to point that out, that it isn't just science, technology, engineering, and math, because those are extremely important. You can't go anywhere without those. But it's the other side of the art side that allows the creativity for people that have an interest in doing more beyond just what you see. 2020 accelerated with COVID the need to understand technology, because we had to do things remotely. Distance learning and working from home was a difficult thing for many people. And it's an area that even today we are still just rebounding from. But these were all starting to work in those types of trends, but quickly they accelerated. Almost overnight, people had to make a decision of how they were going to do this, how they were going to engage with technology. We were starting to work from home in ways that we never imagined. Data took off and has not even looked back. Not everything that is measured is important, and not everything that is important is measured. We should all be looking for new answers and new technology. But we need to understand that everything that we currently measure isn't always the most important thing, and that everything that is important can't always be measured. We try to do better with that. There are new sensors every single day, but they don't provide all of the answers. And this is a kind of takeoff on what Albert Einstein had said. Just remember that keep working towards improvement. This is some of the things that we need to encourage students to do, is not to just accept information the way it is. All data is certainly not created equal. Think about the supporting documents that we have to gather. There's an old saying, in God we trust, all others bring data. And it's kind of funny, but it's true. We want to see the data. We want to see the information to prove what we believe. Analytics has changed. You think about how an old pie chart used to be. Look at this one here. We used to have just these small sections here, and this is how we broke things up. But now we have all these little subdivisions within these pie charts. That's an incredibly important aspect, because the more deeper we can break things down to the minute detail, but also have a more macro approach, because we need to understand how things are from both levels. Where does it fit? What piece of the pie does it go into? But then each one of those little smaller slices has very important data of where it comes from. I could talk about how, when I look at temperature, what difference something makes, and I can group everything together under temperature, but I may need to break things down on the impacts of what brought that temperature up. Was it the people that are in the room? Was it the actual ambient temperature? Was it the cooling system itself not being able to cool as efficiently. All of these things break down in little small pies, but can be grouped under that umbrella of temperature. Visual displays have expanded far beyond our desire for knowledge even. There's so much more, and the way we look at it is very important because different charts tell you different things visually as you look at them. When I want to break things up, the nice thing about, let's use a pie chart as an example. One of the nice things is that no matter what I do, 100% is 100%. Even if I remove one of those pieces of the pie, 100% is 100%, period. And it's going to be broken down into those each slices. That may not be as effective as times where you might need to actually be able to compare line graphs and bar charts. All of these have different roles in technology, and analytics has really expanded a lot, and it's just the tip of the iceberg when we talk about artificial intelligence. Benchmarking. You think about benchmarking, what that means is, what is it we're measuring? Where did we start today? Whether you like it or not, it doesn't matter. You start at the beginning. That's a very good place to start. Make sure the beginning is the beginning. We may be picking up in the middle of a measurement because that's all we have. We can't go backwards and go get a measurement. We can only go from today forward. So understanding that aspect is very critical. When you're measuring things and you're trying to look at how the diameters or how quick something wears, we want to be able to do that using this technology. Artificial intelligence has become unbelievable. I know I keep using that word unbelievable, but it really is. Technology-wise, artificial intelligence has given us the opportunity to look at things in a very different way. We now have details and we piece them together and we weight them differently. Each little part of that is only a small piece, but that small piece may be weighted at 80%. That little piece of data may be 80% of the influence when we talk about artificial intelligence. Predicting versus responding, how we use artificial intelligence has changed that. We used to respond when something broke down, we would figure out, or we would just guess in the future of how long something would take, and we would do predictive maintenance. Well, preventive maintenance is something you're just doing. You don't really know when it's going to break down. Predictive maintenance starts taking into effect some of this artificial intelligence and details to try and piece together the future. A lot of things are manually adjusted. When you look at something, let's say this is our person who's working in the field. Data comes in here, and even if it's cloud received and it's IoT comes out here, or Internet of Things, they're gathering these sensors, and then he makes a decision and goes and makes an adjustment based on this information. Now, that's only one piece of it. Now, in the real world, the sensor comes in, it goes in through an interface, it goes out, it's communicated out here to the cloud. Something's happening out here where he actually gets to see this information. And meanwhile, in between, there's processing going on. So those things are all part of that piece that goes into the manual process. Now, when we talk about predictive versus preventive, there's a lot of sensors out here, and I'll kind of use this example. We can read back information like a bearing failure or a belt wear. That's fine. And checking for information, this is all good. But if you realize one thing, this is just telling you the data. You're still manually having to go make that decision and make things happen. So there's nothing different where he's actually getting this data. It's just coming in a different manner directly to him. If you think about a line being linear, well, seldom is that the case. There's usually some variance in here that we need to address for. So now we can more customize for what the data is actually telling us. And it's more accurate this way. So the more data points we have, the better off we are. Think about removing our person from this operation. The information comes in, he tells the cloud computing or the interface what he expects. And from that, the decision's going to be made without him actually doing the work. He had to put in some parameters, but it's being done without his actual work. A lot of this leads into machine learning, what we consider AI. Okay, there's different aspects. You have machine learning, you have neural networks, you have natural language, where you can actually, the words we use actually do mean something. There's an evolution along with that. There's systems that are experts, and some level in here of computer vision system that goes along with robotics. Well, when we think about AI, think about machine learning, deep learning, and neural networks. Imagine being born with no sense of smell and having to figure out its impact on your sense of taste or your perceived sense of taste. So think about that. If you were born and you couldn't smell anything, many people think that taste, oh, I taste this, this tastes like this. And we use that word, but that's really not what we mean. What we really mean is we smell something. And imagine if you didn't have that, but you had to try and understand what that information was. That's where we are kind of with AI is we're hoping that our machines can learn and process information, but they're not the same as us. So we have to explain things in a little different way. We have to actually build these neural networks. Okay. So we have to build the network, but it has to go beyond the cloud. It has to go beyond the aspect of a printer that prints. Think about printing a 3D scent cartridge so that you could know what a flower smells like. Think about that in the future, that you could do that, or educate somebody who's a diabetic caretaker, or even we do with dogs right now, where they can sense the chemical makeup when somebody's having a diabetic incident. All of these kinds of things go into it. Imagine if we could do that and learn, or we could at least teach that. Now, we usually think of neural networks that it goes here, we think of here, and it's just a straight line. Well, it's usually not. There's different options that go within a decision. It doesn't go from A to B straight. It's usually through some other decision. If a sensor just measured something and it gave an output, that would be terrific. But that's not what we have. We have a system where it actually has to go through 3 other decisions and measurements, and they're not always the same. They're not always used every day. So we need to understand these networks that have to happen. Think about self-teaching. We want a robot to learn what to do. Okay. If we have this robot pick up, here it's picking up corks and it's placing them in another place. And then all of a sudden it has to pick up a wrench. Well, the problem is that the wrench is going to require a different range of motion by the hand or actuator here, or it's going to have to move that. It's going to need more torque to lift a wrench than it does to lift up a very light cork. The end effector has to be able to grip it differently. The program has to allow for the change of weight and how much current it's going to take. All of these things have to happen, and to expect the robot to do that on its own or to learn that is a little bit asking quite a bit. But we're getting closer to this all the time, where the robots are learning themselves and making these neural networks. So we're going to ask the machine, we're taking our guy out of here, we're asking these neural networks to improve on their own, to take the information and get better at figuring out and problem solving. That's what we're really asking them to do, is get better at that. Some of the challenges that we have, of course, within networks, natural language. You and I might see that as the Big Apple, New York. Okay, well, all of these represent New York in a different way, but the program would never accept them as all meaning the same thing. It would look at it and say, no, none of those are the same as this. None of them are the same as this New York Big Apple. You might say it's a distinction without a difference, but to a computer, it is a difference because they're not the same thing. What's pi? Well, you might think 3.14. Somebody who's very detailed might think that is. And they would not compare the two and say that they're both equal, because they're not. Think about what is something that happens and what is a cause and effect. So if we're here and we get everything's going along fine and the machine's extending the cylinder and you have motion, all of a sudden it hits resistance and the pressure goes up and the cycle switch sees that it's not moving, so it changes state because there's no motion. Well, what was the cause and what was the effect? Okay, understanding that, it may sound simple that, well, it reached the end of its travel and therefore there was no motion and the pressure went up because it hit the end of it, the travel, and the cycle switch changed state. Yes, but what is the cause and what is the effect? If you're asking a computer to figure that out on its own, you have to have programming that responds to that. So you need to think the question of what happened. Now we relate to this and we say, okay, there was no motion, so it's just fine. But we need to be able to understand this better. Display dashboards. There's a lot more out there now for displaying data. So we know when things are happening, what's going on. They're green, they're running; yellow, they're paused for some reason, and the details beyond the reason, and how long till it's projected to finish. These display boards are very helpful, and they give a visual feedback to us. How far do we still have to go? Well, let's think about it here. If you take out your phone and ask for a restaurant that is nearby but is not McDonald's, try it and see what happens. It's going to show you all the restaurants that are McDonald's because it does not understand not McDonald's. So natural language process is something we need to have to work on. Keywords. I've said this before. Sometimes we think that we're teaching the computer, but the computer's teaching us because there's words it wants to hear. Alexa, computer, those are words that it wants to hear as a trigger. But what it doesn't want to do is just do whatever you tell it in a very normal language. So we have to respond to that the right way. Artificial intelligence, how are we responding to things now? Those are changing constantly. The computer algorithms, like Amazon's model of how it's interpreting you and building a profile about you, is pretty amazing. If you think about what it does, what it takes in, and how information gets transferred back to you. We need to have a certain set of parameters because we need to set the scale for our expectations. Worst thing that you can have is unfulfilled expectations. That leads to disappointment. AI goes awry. Well, do we need to worry? Well, if you think back at 2001, A Space Odyssey, what are you doing, Dave? Well, people smarter than me have certainly thought that there are some concerns. There were the chat bots, when they left to themselves, develop their own language to communicate with it. That's a little creepy. Stephen Hawking warned of potentially dangerous consequences of AI. So he sees that there were some hazards in what AI can do. Elon Musk says that AI is one of the biggest existential threats. We have to look at, just like Asimov's laws of robots, of how do we make sure that humans are protected when using these robots and AI and all this information. We have to keep expanding and getting smarter, but we have to also think that our next generation has to be smarter than us. They have to look and predict what the problems are going to be in the future. So congratulations today for being smart. If you need to reach me, here's my information. I want to thank Dr. Tantawi again for putting this together, and go out there and make it a great day.